Hi. So before I start with the, can I switch the slides with this one?
Oh, the slide.
But the pointer is working. Okay, so just use. Yeah. Before starting with the real presentation, I just wanted to start with a shameless plug. Oh, I don't know. Please stop. Okay. Hopefully it's working fine. Yeah, with a shameless plug about another venue of digital classics conversation. And this is a seminar we started last year in Berlin. This just to show how the digital classics community is really decentralized in many places and trying to build an international conversation about these topics. So we started last year with the first edition of this seminar, which is made after the Digital Classics Work in Progress seminar that has been running since 2007 in London. So we got it working, it's finished last March, and all the videos of talks and discussion are online to give away to people who cannot be there to still join in and participate to this kind of conversation. So this is the website, and there is a playlist with all the videos in the YouTube channel of the German Archaeological Institut. Okay, so the work I'm going to present today is about my PhD research, and I thought about starting with this quotation because this is a great summary of basically what I'm trying to do in my project. So Crane wrote in 2009, scholarly disciplines such as classics need specialized named entity searches. We need to determine not only whether TH 1.38 is a citation to a primary source, but also, if so, whether it designates Thucydides Book 1, Chapter 38, Theocritus Civilis 1, line 38, or some other text. In some other disciplines, like for instance biomedicine, the named entity extraction of entities that are of particular interest in that domain, it's a topic which is heavily researched nowadays. And named entity recognition in general has been around for some 30 years or so. So what Crane was saying is that we need some named entities that are of specific interest to classicists. And this is what I'm trying to build and to extract automatically from text. So the scope of my research is modern publications from the 19th century onwards. What I'm trying to do is to devise new and more effective means of accessing possibly large corpora of text. And the specific way I'm trying to do this is by capturing these named entities that Crane was referring to, namely citations to primary sources, the canonical citations. And I'm so happy that I'm talking to an audience to whom I don't have to explain what canonical citations are, because they're all well acquainted with that. And the way I'm trying to do this is by applying, not inventing new things, but applying and reusing and adapting tools that have been developed for, as I said, the last 30 years in computer science, in the NLP field, to extract named entities from text. So this is the big picture of what I'm trying to do. The input are modern publications, commentaries, journal papers, abstracts, whatever you want. And the core of the system is a system to extract citations automatically. This relies on a knowledge base. A knowledge base is basically trying to supply the system with some domain knowledge that the machine doesn't have. For instance, TH can be an abbreviation for Thucydides or Theocritus and so on. This is knowledge that a human being has, but not the machine. So we need to supply our software, our machine, with this kind of knowledge. And this is done by the knowledge base. Once you have extracted citations from text, then you can do a number of interesting things. One is semantic publishing, basically trying to link automatically the text of a journal papers to the cited text in it. Or one of the most interesting is semantic information retrieval. So you take a corpus like JSTOR and you allow the user to access the journal articles in JSTOR looking for specific entities. In this case, for instance, looking to a citation to the first line of Homer's Iliad or Odyssey. This is what we define as semantic information retrieval. So this is the big picture. So why canonical citation? Yeah, this will speed up a little bit. But why canonical citations are important? First of all, because they refer to the very object of research of classicists, that are the text. And that they are a nice example of pre-digital text interoperability. Classicists needed to know what they were talking about when they said, when they were saying home or one independently from the specific edition they were talking about. So it's an example of having an agreement about what we are talking without referring to a specific edition. So there are some challenges in capturing canonical citations. One that we saw already is the ambiguity. You can have abbreviations referring to different name of authors or multiple works. And this needs to be disambiguated somehow. Another challenge is the alternative forms for the same thing. So you have the same canonical citation, but you have very different ways of expressing it according to, for instance, the audience you're writing or you're writing for. Like in a journal focusing on Homeric epic, for instance, you will find Hellenistic citations to the Homeric poems rather than this longer form, just because there are many of them in a single journal paper. As I said already, there is some lack of implicit domain knowledge. For instance, the idea of the opus maximum. You can cite an author, leaving out the work you're referring to, if this is the opus maximum of that author. So when you refer to Celius, you can just say Celius and then give the book and line. And this has to be supplied somehow to the software. Then canonical citation, although they are somehow standardized and canonical, they occur in a context which is discursive, and they tend to adapt to this context. So you can find the same citation not expressed in this way, but in a more discursive form. And the more it's discursive, the more it's kind of difficult for an automated software to capture it. And then a big problem is that there is a lack of resources to build these kind of systems. So in other fields like bioinformatics, there are corpora already annotated with the named entities of interest, like name of genes or proteins. And in classics, we don't have this. So a great amount of time is spent trying to create the resources that allow us to build this kind of tools. Why do we want to do this? I will focus more on this part. My idea is that to study intertextuality in the 21st century, we need two kinds of systems. One kind of system is to discover automatically candidates for intertextual phenomena. And this can be done by text reuse or allusion detection. And I'm really glad that I'm talking about these kind of things here, where Tessere was developed, and Marco is also here. So this, in a way, to expand the traditional commentary. On the other hand, it's also important, beyond discovering passages that have not been studied before, also tracking the parallels that have been already studied over time. And this can be done if we capture canonical citations in corpora of text. The point is that there are so many citations that we want to do this automatically. And in the next part of the talk, I will go into the details of how this can be done automatically. So this is, once you have extracted the citations, they can be viewed and browsed and explored at three different levels. The first level is at the level what I call macro, but at the level of the author. So let's explain a little bit what the nodes and the edges mean. So the green bluish nodes are the author, the ancient author that have been cited, and the red nodes are the publication. Publication can be a journal paper or a commentary, it doesn't matter. And whenever you have a citation from a publication to the author, you have an edge, a link from a node to another node. So even if the citation is from one publication to the first line of the Odyssey, you can abstract this to the author level. So you have a citation, a link between a publication and the author. And when you start exploring a bigger corpus, then you can see some nice classes of publications be referring to the same author. So you might want to start browsing your corpus at a higher level, and then drill down into the content. For instance, expanding a node that you're interested in and seeing what are the specific works being cited by a given publication. And then you can do this down to the passage level, because some people might be interested in generally the Odyssey, some people may be interested in a specific passage of the Odyssey. So this is how no. Okay. So this is how the citation network can be somewhat visualized. I will focus now on the part of the citation extraction. I actually divided the task of extracting citations in two parts. One part is about extracting the citation, so determining that these two words are actually one citation, and the other part is what I call the citation resolution, which is still work in progress. And it's about determining that that citation is referring to this specific text. So I'm considering in my work two corpora. One corpus is JSTOR, that I'm sure you know, and the other one is RNA philology. So they are two very different type of texts, and they both contain the kind of citations I'm interested in extracting. So the JSTOR is very comprehensive because contains, I can get the full text OCR of 70,000 papers in classics, spanning over 2 centuries. On the other hand, the OCR can be noisy, so you have problems with the quality of the OCR. Then there are other problems, for instance, with the, I started getting this data using the JSTOR API, and then also due to some dramatic circumstances, the API has been progressively closed down. And now if you want to get the data, you have to sign a license agreement, and can take a long time before, actually to me it took 1 year before I was able to get the data. So it's a really valuable corpus, but not necessarily easy to get. On the other hand, the RNA philology is not available openly either, but I was able to get the data for 1 volume. And it's extremely, they are very short texts, but very dense in terms of canonical citations. And they are transcribed, so very clean text, you don't have to deal with the problem of OCR. So the main idea of the system I'm trying to build is to create a corpus annotated with the information that you're interested in, and then try to train a software to extract automatic citations based on that training corpus. And the corpus I've created is about 30,000 tokens. I focus on 1 single volume of the RNA philology. And to give you an idea of the scale, I took only 8% of 1 volume, and this gave me already 30,000 tokens. It's a multilingual corpus, so you have the text in the 5 main languages of philology. And there are 2 kinds of annotations. The first one is the part of speech tagging, and the second one are the named entities, and we'll be seeing in the next slides what are the entities I'm focusing is released under Creative Commons license, mainly because, as I said, there is a lack of resources. So what I've done for this specific task, I wanted to be reused for possibly other software that can do the same extraction of citation. So this is an example of an abstract that you can find in the philology, and in bold you see the citation. So this is a kind of discursive citation that I was referring to before, and here you have more structured and easily identifiable citations, and and here the case of the opus maximus, where you can leave out the word and just give the name of the author to refer to his opus maximum. This is the annotation scheme I've been using, so these are the entities that have been annotated in the text. So I distinguish between the name of ancient authors, the title of ancient works, and the idea to capture these entities is that sometimes if you isolate them, you take only one abbreviation like TH for instance, it's not enough to disambiguate what that TH means. So if you capture the entities in a broader context, then you are able to recover some of the context that is otherwise missing. So these are the two kind of entities. Then there is an in-between entity, which is a reference to an author or a word. Because in some cases, the boundary between is this a reference to the word or to the author is kind of fuzzy. So with this entity, I capture the reference to the author or the word in a canonical citation, so in a structured way. And then the scope of the reference. This actually should be here, but never mind. The scope is the specific text passage the citation is referring to, usually a sequence of numbers. So these are the entities I'm annotating. Here you can see the same example with the annotated entities. So you see the name of the work, then the scope. And as you can see, the scope can be attached either to a work or to this reference to an author or a work. And as you see, I broke down the canonical citations into pieces. So the different pieces are treated as named entities. And then there are some relations identified between these different named entities. And this is all encoded in the corpus. And the second level, which is referring to what I called before the resolution of named entities, is actually disambiguating the citation. So like in this case, you have this scope relation between TH and the scope, and we disambiguated assigning a CTS URL to say to which text passage is this citation referring to. But this is not yet done automatically. How much time do we have?
You'd be slightly over already. So.
Okay.
But maybe a couple.
So this is the kind of machine learning approach I was mentioning before. When you take a text, you annotate it, extract some features, and then train a statistical based model basically. That the model that we do is trying to assign the right label to a token given a series of features. And at the end, you're able to let the classifier tag a passage that has not been seen based on some training that the software has received. I think I will just, I'll cut it down a little bit. I will skip over the features that I've been using and also the annotation process. Just a few words about the process. The main idea behind the process that I've been using is that instead of selecting randomly the entities for the annotation, I go to select those that are more tricky for my software to catch. So basically, I'm looking at those citations where the software has more problems in determining if it's a citation or not, and then I use this, I annotate this manually, and I feed them into the system. And then I did some basic evaluation using the usual measures of F-score, precision and recall, to measure how well the system is able to extract the different entities. Yeah, that was me.